Let's say as part of downloading multiple files, we want to show the total number of bytes we have downloaded so far. So we need to store the total value somewhere and have multiple threads incremented as they are downloading files. This is going to cause a race condition, which means multiple threads racing or competing to modify a shared resource. Let me show you. So I'm going to add a new class in this project. We call it download status. Here we need a field for storing the total number of bytes we have downloaded. So private integer total bytes. Now let's create a getter for this field. So we put the caret on the field name, press Alt and Enter, and create a getter. We also need a method for incrementing this field. So instead of adding a setter, I would prefer to add an increment method so each thread can call this to increment our field. It prevents us from accidentally resetting the total bytes in a thread. So public void increment total bytes. And here we type total bytes plus plus. Now we want all our download threads to report to a single download status object. So in our demo class, let's create a download status object, new download status. Now we start 10 download threads. So let's add a for loop for I equals 0, 10 times plus plus. Here we create a thread, new thread. Here we pass a new download file task. We start a thread. Now we should pass this status object to each download file task. So let's pass it here. Now we let IntelliJ create a constructor for receiving this value. So we press Alt and Enter, create constructor. There you go, pretty easy. Now we should create a field to store this status object. So we press Alt and Enter here one more time and create a field for parameter status. There you go. So here's our field and we're setting it in the constructor. Now let's change the run method a little bit. Instead of integer.maxValue, let's use 10,000. So we want to simulate a scenario where each file is 10,000 bytes. We can also add an underline here. This makes our code cleaner and more readable. So in each iteration, we call status dot increment total bytes. Now we don't need this message anymore. So let's simplify our code. Now back to our demo class. We are starting 10 download threads and sharing a single status object across these threads. Now, once all these threads are complete, we should print the total number of bytes we have downloaded. So we have to wait for all these threads to finish. Now, we cannot call thread.join because this will make the main thread wait for each download to finish before starting another download. Because this join method is a blocking method. So in the first iteration, we create a thread, we start it, and then we wait for that thread to finish before going to the second iteration to create a second thread, okay? So we can use the join method here. We should start all these threads simultaneously and then join with all of them. So let's declare a list of threads, a list of thread. We call it threads and set it to a new array list. Now, every time we start a thread, we add it to our list. So threads.add thread. Now here we need another for loop to iterate over all these threads and join with them. So for thread in threads, we simply call thread.join. Now once again, we should handle the interrupted exception. So let's do it real quick. So with this for loop, we can wait for all these download threads to finish. Then we can print the total number of bytes we have downloaded. So we call status.get total bytes. So here we have 10 download tasks, and each task is going to download 10,000 bytes. So when I run this program, we expect to see 100,000 bytes, but that's not going to happen. Let me show you. So run. So we saw 78,000. If I run it again, we see a different number, 72,000. One more time, 71,000. This is a race condition in action because multiple threads are racing or competing to update the total number of bytes. Now let me explain what happens under the hood. So back to our download status class. Look at this increment operator here. This operation involves 3 steps. So even though we have only one line of code, there will be three steps happening under the hood. First, the value of this field has to be read from the main memory and stored in the CPU. Next, the CPU is going to increment this value, and then the updated value is going to be stored in the memory. So we have three steps, and we call this a non-atomic operation because it involves multiple steps. In contrast, an atomic operation is like an atom. We cannot break it down into many steps. Now, imagine two threads trying to call into this method at the same time. Let's say the value of this field is 0. Both these threads will read this value concurrently. They both increment it and write it to the memory. So the result will be 1 instead of 2. This is how we lose an update. In the next video, we'll be looking at various strategies to prevent these problems.